Welcome back to School of Physics. In this lecture, we are discussing about the Newton's third law of motion, because in the earlier sections we have been talking about the first law of motion, the second law of motion, and now it's the time to discuss a few things about the Newton's third law of motion. So till now we were discussing how to calculate force. This was given by the Newton's second law. Okay, if a body is there, if we are applying a force onto it, how to calculate that very force. For that we should be known about the acceleration, velocity stuff and all that. We can also calculate from that by using the impulse. Okay, so now what about if a force is acted onto a body A? Suppose this is a body. There are two bodies. This is a body A here, this is a body B here. If, for example, what about the bodies if we apply a force onto this by some agent? Okay, we can calculate the force, and this in turn means that is there a possibility that B is also applying a force on something A, if it is applying force onto this? Say, for example, what I'm saying, this is quite observable in some cases, like if this is a spring and I am applying a force like this, but with my hand. Okay, if I am acting a force onto this, it will be compressed like this. Now we'll feel an outward push by this spring. Okay, that is the spring force which I discussed earlier. If I am applying force with my hand, I will feel a similar force from the spring outwards. Okay, so in that case, I can say that, oh yes, the spring is also applying the same force upon my hand. But what about the two bodies which are at a distance, still applying a force upon each other? Okay, say this is a body which is called as the Earth. Okay, this Earth, and some stone is dropped from here under free fall. Okay, we know that it will get down because there is a kind of gravity there, and it will be accelerated under the effect of the gravity, and the gravitational force will be applied onto this body. What about this very body? If this is a body A and this is a body B, what about if A is applying a force on B, that is gravitational force here? What about B? Is B also applying the same force on a body like the Earth? The answer is yes. And this yes was said by Newton himself. He said that even though these two bodies are at a distance, if A is applying a force on B, like FBA, that is the force on B due to body A, then same force will be applied onto the body B, on the body A, that's FAB. Okay, so we have got two bodies, which this very is applying a force on this, this is body 1, 2, so force on body 2 due to 1, then in the similar fashion, force will be applied on body 1 due to body 2. This is called by the Newton, and is famously called as the Newton's third law. That means what Newtonian mechanics says that it is always happening in nature that forces, if we apply onto a body a force, it will not happen singly. There will always be a reactive force, a force generated by that body in turn. Okay, so we can say that forces never occur singly. Okay, singly in nature. Fine. And that means what? That means forces are always generated in pairs. Forces are always generated in pairs. Okay, they occur in pairs. And another thing he said that it's not only in the pairs, but there is a generation of the equal amount of force, but in the opposite direction as that of here. If this force is applied onto this in this direction, then the same force will be exerted back, but in the opposite direction. So there is a mutual forces between the two bodies. There's a mutual there. I can write it like this: the mutual, because this is same force applied this by this body onto this, and in turn this will act in the similar fashion. So mutual, there will be a kind of relation, like mutual relation. Okay, mutual forces between two bodies are what? Equal and opposite. This is the main statement which was given by Newton, that the forces are generated by both the bodies. If first body applies a force onto the second, then in turn force generated by the second will be same as that of the first, but in the opposite direction. That will be equal and opposite. So he gave a statement which is famously called as the Newton's third law, and is commonly used by the common pupil also, not only the physicist. And that is the third law of motion. Third law of motion. I will write it down like this: to every action, there is always an equal and opposite. These two terms are very much important. Equal and opposite reaction. Fine. These two terms. There is always an equal and opposite reaction. So to every action, there is in turn a reaction. Okay, a reaction is generated in the back. Okay, so third law says that if a body A applies some force on body B, then in turn B applies a force on A, but that will be equal but in the opposite direction. So there's a kind of action and reaction relation between the two, but there are few wrong impressions which have been which are common in the among the pupil.